Hello dear students, this session is all about the chapter carbon and its compounds. So firstly we would like to go along with the introduction related to this topic, that is carbon and its compounds. And what is actually carbon? It is an element, isn't it? And its symbol is represented by capital C. Its atomic number is 6. Therefore, its electronic configuration can be written as 2, 4, which means 2 electrons are present in K cell and 4 electrons are present in L cell. Then with reference to this electronic configuration, the valence electron present in carbon will be 4, and therefore its valency will also be 4 without any plus or minus sign, because elements which have a valence electron 4 cannot become stable by losing its 4 valence electron, neither can become stable by gaining 4 electrons. Okay, so therefore the option left for the elements with 4 valence electron to be stable is by sharing of electrons. Then the type of element which carbon belongs to is non-metal, because its valence electron is 4 and valence is 4. Now, what is its position in periodic table? Since its atomic number is 6, it will occupy the 6th place in the modern periodic table. Carbon is the 4th most abundant element in the universe. Therefore, which is the first most abundant element in the universe? It has to be hydrogen. It can exist in free state as well as it can exist in combined state in the nature. I am talking here with reference to carbon. So in free state it will exist as diamond, and it can also exist as graphite. Okay, so I have shown the figure alongside the diamond and the graphite. In combined state, it can be found in all the organic and inorganic compounds. Organic compounds means it is related to organic or living things, and inorganic compounds which are found in the nature and artificially prepared. So this is the table pertaining to the combined state of carbon in organic and inorganic compound. Table 9.1 gives us an information about carbon containing inorganic compounds along with their chemical formula. Like gases, carbon monoxide, you can see that the carbon is linked to one carbon atom, hence its chemical formula is CO. Likewise, carbon dioxide, its formula is CO2. Here you can see that the carbon is linked to 2 atoms of carbon. Likewise, some of the salts like calcium carbonate, calcium bicarbonate, magnesium carbonate, magnesium bicarbonate, sodium carbonate and sodium bicarbonate, that is baking soda, all contains carbon, but this carbon is existing in combined form. For example, magnesium carbonate, whose formula is MgCO3, you can see that the carbon is linked to magnesium and oxygen element. If you come to the right hand side, that is table 9.2, this table gives us an information about the carbon containing organic compounds and their chemical formula. So these organic compounds have been classified into hydrocarbons, alcohols, acids and sugars. Hydrocarbon means these are organic compounds which is made up of only 2 elements, that is hydrogen and carbon. For example, methane, you can say its formula CH4. It consists of only carbon and hydrogen. Likewise, alcohol will contain hydroxyl group as their functional group. For example, methyl alcohol, whose formula is CH3OH, and ethyl alcohol, whose formula is C2H5OH. Ethyl alcohol is the component that is found in commercially available alcoholic drinks, and methyl alcohol is poisonous. Coming to acids, carbonic acids, acetic acid and formic acid, these are the organic acids. Like carbonic acid is formed when carbon dioxide combines with water, and it is found in carbonated drinks like Coca-Cola, etc. Acetic acid is also consumable in the form of vinegar, whose formula is CH3COOH. Formic acids, its formula is HCOOH. In all of these compounds, you can see that carbon is present in combined form. Coming to sugars like glucose, maltose, sucrose and starch, if you look at its formula, you can find that carbon is one of the elements present in these compounds and in combined form. Carbon is taken to be an integral constituent of items like wood, paper and soap. All these are organic in nature, and soaps can also be inorganic, prepared with the help of some chemicals. Complex molecules, for example, if you take blood, hormones, for example insulin, RNA, DNA, which is considered as the genetic material, and enzymes, for example salivary amylase, found in organisms, all contain carbon. Human body also contains carbon because we are organic in nature. Occurrence. Now I have a very small flow chart which will help you to organize this subtopic, that is occurrence of carbon in nature. So in nature, carbon can exist in combined state and it can also exist in free state. In combined state, it may be in the form of a solid, for example limestone and marble. It can also exist in liquid state, for example petroleum. Petroleum is a crude product. If petroleum is fractionally distilled, then we get product like kerosene, petrol, diesel, etc. It can also exist in gaseous state, for example carbon dioxide. In free states of carbon, we'll study diamond, we'll study graphite and we'll study coal. Okay, all this, that is coal, graphite and diamond, are the free states of carbon. Coming to unique property of carbon. Carbon has a unique property that it can combine with other atoms of carbon. So carbon has a unique property of joining with other carbon atoms to form carbon-carbon bonds, which means the two carbon atoms can join together with the help of a covalent bond between them. The property in which the atoms, that is the carbon atoms, join together with other carbon atoms, thereby forming long straight chains, branch chains, and as well as ring-like structure, is known as catenation. In simple words, I can say that the self-linking ability of carbon atoms to join with another carbon atoms to form straight chain, branch chain or ring-like structure is known as catenation. So here you can see in the diagram a chain of carbon atoms arranged in a straight pattern. Here you can see that the carbon atoms are in straight chain as well as they are branched also. Here you can see that the carbon atoms are arranged in the form of a ring. Coming to isotopes. What are isotopes? We have already studied. Isotopes are the elements which will have the same atomic number but different atomic mass. So with reference to carbon, carbon exists as 3 isotopes. Number 1, carbon 12, carbon 13 and carbon 14. Okay, here 12, 13 and 14 represents the atomic mass of the isotopes of the carbon. So if I have to represent this carbon 12 symbolically, then I will be writing it as C612. And how are we supposed to represent carbon 13 symbolically? C613. What about carbon 14? C614. In all these Examples, you can see that 6 is the common number, that is the atomic number is same, and 12, 13, 14 represents the mass number which is different. Coming to allotropy. The phenomena due to which an element can exist in different physical forms is called as allotropy, which means in nature there are some elements which can exist in more than one physical forms. Fine. And all those different forms of that same element will be considered as allotropes. Alright. So classifying carbon, you can see that carbon can exist in crystalline form also, and it will have amorphous form also. That means the allotropic forms of carbon can be of two types, that is crystalline form and amorphous form. Under crystalline forms we have diamond and graphite. Under amorphous form we have charcoal, lamp black, coke and carbon gas. We'll be studying in details about this in the later session. Charcoal can be further classified as sugar charcoal, bone charcoal and wood charcoal. For the time being, just observe this chart carefully. You should be able to classify the allotropic forms of carbon this way. Note, you have to keep it in your mind that the allotropes of that particular element will have different physical properties but will have the same chemical properties. For example, take two allotropes of carbon, that is diamond and graphite. Diamond is the hardest substance in the world, but what about graphite? Graphite is a soft material, isn't it? So the physical property of diamond and graphite is different, but both of them will exhibit the same chemical property. Why? Because diamond is also made up of only carbon atoms and graphite is also made up of only carbon atoms. Alright. Then carbon, I told you carbon will exist in two different allotropic forms, that is crystalline form and amorphous form. You should know the difference between crystalline form and amorphous form. So let's go through it. Crystalline forms of carbon will have a definite geometrical forms, that is it will have sharp edges and plane surfaces. However, amorphous form of carbon will not have a definite geometrical forms, that is sharp edges and plane surfaces. And the examples of crystalline forms of carbon can be taken as diamond and graphite, and for amorphous form we can take it as coal, charcoal and coke. Coming to crystalline forms of carbon. When I say crystalline forms of carbon, it means that the atoms of the carbon in the diamond, for example, will be arranged in a definite geometrical pattern. Hence they will be appearing in the form of a crystal. This perfect arrangement of carbon atoms will give rise to the formation of a crystal. Crystalline carbon occurs mainly in two allotropic forms we have studied earlier, that is diamond and the other one is graphite. Coming to diamond. In India, diamonds are found in Panna mines, which is located in Madhya Pradesh, and Golconda mines, which is in Karnataka. Then all over the world, diamond mines are present in South Africa, Brazil, Congo, Russia, Angola, Tanzania and the USA. Just have a look at this picture. What is the unit in which the weight of the diamond is? The weight of the diamond is expressed. It is expressed in carats, isn't it? And 1 carat is equivalent to 0.2 grams or 200 milligrams. Now the value of the diamond will depend upon its weight and its purity. The more the weight and more the pure diamond, the value of that diamond will be more. Do you know that the largest diamond ever found weighed 3015 carats or equivalent, that is 621 grams? And some other famous diamonds with their weight are Kohinoor, which you have aware of it. It weighed 186 carat, and later it was cut into small pieces, like one of the piece measured 106 carats. Nizam with 277 carats, and Pitt with 136.25 carats. Diamonds are transparent crystalline substance with high refractive index, which makes them shine brightly. So if I ask you a question like why diamonds shine brightly, the answer should be it is because of a high refractive index, which means that with reference to air, the diamond is dense, isn't it? For example, when the light travels from air into the diamond, since diamond being denser than the air, the speed of light inside the diamond will decrease, and before the light from the diamond comes out, it will keep on suffering multiple reflection inside the diamond. That property is called as total internal reflection. Because of this phenomena, it makes the diamond shine brightly. Diamonds may be colored, but depending on the nature of impurity present. So, what do you understand by this statement? If diamonds are colored, it means that there are impurities present in it. A pure diamond will be always transparent. For example, emerald diamonds and black diamonds. So emerald diamonds will have green color, and this green color is due to impurities in the form of chromium oxide. Black diamonds contain copper oxide. This is the reason why black diamonds appear black in color. Black diamonds will not have any gem value, but they have industrial use. That since they are very hard, therefore they are used as cutters for cutting other diamonds. Coming to structure of diamond, it is very important. This is the structure of the diamond in 3D. The purple dots and the green dots are representing the carbon atoms, and the red lines are depicting the covalent bond between the carbon atoms. Alright, if you observe the figure carefully, you will see that the central carbon atom, which is represented in green dot, will be surrounded by 4 carbon atoms, which is evident in the form of purple dots. So what do we understand? In the structure of the diamond, the central carbon atom will be surrounded by 4 carbon atoms, isn't it? So I have the statement, each carbon atom is surrounded by 4 other carbon atoms, and each carbon atom is located in the center of a regular tetrahedron. This network of carbon atoms will provide rigidity to the diamond. The way these atoms are arranged inside the diamond, this gives a rigid structure to it. The hardness of diamond is due to the uniformity of CC bonds. CC bond means the covalent bond between the carbon atoms. Since the CC bond, that is carbon-carbon covalent bond, is very small, therefore it will have very high density. There are no free electrons to migrate in its carbon atoms, so diamond is a non-conductor of electricity. This point is very important. So in the formation of the diamond, isn't it, the carbon atoms will have the electrons, and all the electrons, that is the 4 valence electron of each carbon atoms, will all involve in the formation of covalent bond. So there will not be any free electrons in the structure of the diamond. So if there are no free electrons, the electricity cannot be conducted. Is that clear? So what is the answer for the equation that diamond is a poor conductor of electricity? The answer is, since the structure of the diamond does not have any free electrons, therefore it is a non-conductor of electricity. Coming to properties of diamond. Diamond will have different properties like, number one, we all know that diamond is the word hardest substance. And why it is so hard? Because of its typical arrangement of carbon atoms in its structure. The covalent bond between the carbon atoms are also very strong. It has high melting point. Why? The carbon atoms in the diamond are held by covalent bond, and this covalent bond is very strong. And if it is very strong, you will definitely need what? A very high temperature to break that covalent bond and make the carbon atoms free. Coming to refractive index. Diamond has a high refractive index of 2.415. Due to its high refractive index, it produces maximum total internal reflection and appears sparkling. So I told you that time also, like when the light from the air will enter inside the diamond, the speed of the light will decrease. Reason is that diamond is more denser as compared to air, and because of its high refractive index property, the light inside the diamond when it enters will suffer maximum reflection, which means the light will keep on getting reflected inside only before it comes out. That property is called as total internal reflection, and because of this, diamond has a sparkling property. Effect of heat. You know that diamonds are stable to heat. However, they can be destroyed by intense heat. So when the diamond is heated in presence of oxygen at about 800 degrees Celsius, then what will happen? The covalent bond between the carbon atoms will break and the carbon atoms becomes free, and that carbon will combine with the oxygen molecule and it will form carbon dioxide. However, if you heat diamond at about 1600 degrees Celsius in absence of oxygen, then this diamond will get transformed into graphite. Okay. Coming to chemical activity. Diamond is chemically inert. At ordinary conditions, it does not react with chemical reagents. So diamond does not react with water at ordinary conditions, neither it reacts with air at ordinary conditions. Therefore, it is said to be chemically inactive or chemically inert. About specific gravity. Diamond has a specific gravity of around 3.52. So this high specific gravity is due to closed and compact tetrahedral packing and even contributes to its high density. So why diamond has a specific gravity of 3.52, a high specific gravity? It is because of the compact arrangement of the carbon atom, giving it the form of a tetrahedral packing. Coming to conductivity, this is very important. Conductivity is reference to electricity or heat. I told you that carbon has how many valence electron? 4 valence electron. And in diamond, all these 4 valence electron of all the carbon atoms will be used up for the formation of covalent bond. As a result, there will not be any free electrons inside the structure of the diamond. So if there are no electrons, the diamond will neither be able to conduct heat nor the electricity. What are the uses of diamond then? It's very easy. Diamonds are used as precious stones in the form of what? Jewelry, since it has high shining property. Number 2, high precision instrument. Because of its extraordinary sensitivity to heat rays, isn't it? It can be used in high precision thermometers, which means to get the data accurately. It is also used by eye surgeons, because the sharp-edged diamonds can be used by eye surgeons to remove cataract from the eye with high precision, accurately. You know what is cataract? It's the disease of the eye in which the transparent lens of our eyes becomes opaque due to deposition of calcium oxalate crystals. Okay, and there is no medical treatment, but you have to go for the surgery, which means it cannot be treated with medicines, but it can be cured through surgery. Used in space probes. You know that when the astronauts go to the space, the spacecraft can get exposed to cosmic radiations, which is very harmful. So diamonds can be used in protective windows for space probes, as it keeps out harmful radiations. Coming to the last point, that is the use of black diamonds. I told you that black diamonds will not have any gem value. It does not have a commercial market value like other diamonds. But since they are very hard, they are used in industries in making laser beams in electronics, as needles of record players, for cutting glasses, as well as diamonds. You know, a diamond can be cut only with a diamond, as a tip of deep boring drills, and also for cutting and polishing diamonds. Thank you.